talk about different types of analyzing graphs. So the different graphs that there are line graphs, stem and leaf graphs, and then histograms, which is a way to analyze data. Line plots always look like a horizontal line that represents numbers. So we could have like people that have 2 siblings, 3 siblings, 7 siblings, etc. You could go from 2 to 7, it would be in sequential order. And the x, there would be x's that would represent the frequency that the number occurred. So looking at this line plot, I can analyze this data by saying 3 kids have 3 siblings, if this was number of siblings. Okay, so line plots, the x represents frequency. So x is how many times it occurred. And that's how we're going to have to analyze. We're going to have to keep that in mind as we analyze our data. So looking at the first line plot, I know it's a line plot because it's a line with x's. It says, what are the scores in a card game? So on the bottom, it tells me the different scores. I have a score of 4, 5, 6, 7, 8, 9, 10. And then the x's means how many times it happened. So how many times people scored a 4 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 people scored a 4. How many people scored a 9 would be 1, 2, 3, 4. 4 people scored a 9. So we can analyze our line plots that way. Another way to analyze line plots, mean is pretty intense. We're not going to worry about the mean, but median is helpful. Now when you think about this line plot, what this really means, there's 4 tens. If you were to expand this out, I would have, or 10 fours, I would have 4, 4, 4, 4. What's that? 4, 5, 6, 7, 8, 9, 10 fours. How many fives? 3. 1, 2, 3. How many sixes?
9.
9. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many eights? 8. Oh, I'm done. And we keep going. That's what a line plot does. It's much more organized. It would take so much work to list them all out. I'm not even done. I still have a bunch of 8s to go, 9s and 10s. It's a way to organize your data in sequential order. Anytime we want data in sequential order, we can quickly analyze the mean. Or not mean, median. Median, again, what you do with the median is put them in order, and then you cancel out the minimum and max. You're always getting rid of the smallest number and the maximum. So anytime we have it in order, we cross off from each end, which is getting rid of the minimum and maximum. So I can do that quick with this data set. My smallest number is 4, get rid of that. Biggest is 10. My smallest score is 4 again, biggest is 10. My smallest score is still 4, biggest score is 10. Smallest score, what am I up for? In 10, small, big, small, big, small, big. Now look, my biggest score was 9. You see. And what some people think, they think that the numbers on the bottom is what they should utilize for the median. The number of the bottoms are just the different scores that appeared. It's not the actual score. Smallest, biggest, smallest, biggest, smallest, biggest. Now moving to 5 is my smallest. 8 is my biggest. Small, big, small, big, poofed up. Now 6 is my smallest. So get rid of the 6. My biggest is 8. 6 and 8 and 6 and 8 and 6 and 8 and 6 and 8. Then I only have 6's left, which clearly is just going to be a 6. So you can analyze your median nicely. Again, only worrying about the x's. You don't worry about the numbers that the line created. You worry about the x's. That's what you analyze. line plot, how many team members scored exactly 4 goals? So what? What do you got?
4.
Yeah, 4. You go to this goal scored, 4, and how many X's? 1, 2, 3, 4. 4 team members scored 4 goals. How many total team members? Write that down. That's a goodie. Total, instead of the mean and median that some of you have in your notes, write total members. That's more appropriate. That's what you'll see. So how many teammates? Well, you count the X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 teammates. You see how I did that? It's not 5 teammates or 4 teammates. It's 18 of them. Counting all the X's. So that's line plots. Line plots is a line that has X's. X's represents a frequency number. 1X represents 1. The next thing is stem and leaf. A stem and leaf plot is used, it's helpful to separate data. I'm going to make a data set for you quick. 34, 33, 20, 26, 41, 9, 17. So here's just a random collection of data. Now we can list them in order, or we can have them in a little bit more advanced way to organize called a stem and leaf. Meaning that I know my numbers go from the 1s to the 40s. So you can have a stem, which means you represent your 1s values, your 10s, your 20s, your 30s. How we do that? I would say my 1s, 10s, 20s, 30, 40. Those are my stems. Stems means it's constant. This 1 means everything after the 1 is in the 10 spot. The 2 means anything after the 2 is the 20s. So here I have a 1 of 9. That means I have 0, 10s, and a 9. In my 10th spot, I have a 17. I would put a 7 there. It would be 1 and 7, 17. In my 20s, I have a 20. I would put a 2. And I have a 6. So I have 2 turns in the 20s. I have 20 and 26. In my 30s, I have a 33 and a 34. So I'd have 33, 34. And then in my 40s, I have a 41. So I have a total of, when you talk about total with stem and leaf, you count the leaves. I have a total of 1, 2, 3, 4, 5, 6, 7 different numbers. Now here's the thing about stem and leaves, and this is what I, notice that you only have one value here. The leaf represents a digit. Meaning if I wanted to represent 111 with a stem and leaf, you can't go 1/11. Because when I look at this, I think 11 and another 11. Okay? Each different leaf is a number. When you do this, you would have to say, hey, you have numbers in the 111, and it would be 11 with the 1. And then you could do 112, 113, okay? That's how you read the stem and leaf plots. Okay, let's analyze it. Games show scores. So it looks to me like I have stems going from 1 to 6, and my leaves are all my different scores. How I read this would be, the first one would be 11, and then 15, 20, 29, you see it? 39, 41, 51, 54. So you just always start with that step. How many people scored fewer than 27? So I would go to my stem of 2, 27 would be right there. Smaller than 27 is 1, 2, 3. 3 people scored less than 27 points. The next one, how many buildings have exactly 23 bricks? So 23 would be in the stem of 2, 23 and another 23 2 buildings have exactly 23 bricks? Okay? And then ages. What is the age of the oldest person on the stem and leaf class? Tell me.
90.
90. I go to my biggest stem, 9, and the biggest leaf on it, so 90. How old's my youngest person?
20.
20. And how many people did I document ages for? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I documented ages for 21 people. Again, when you talk about the total set, would be all the leaves. How many bags had at least 28 buttons? So 28 would be right here, but there's not one. So I have to go down to the stem of 30s. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 bags had at least 28. Here's what some kids have asked. Does this 4 mean 40? What do you think?
No.
Well, how many terms are in the 4 T's?
None.
None. But we just have to go in sequential order. 2, 3, 4, 5, 6, 7. Notice they just didn't skip past 4. But if there was a 40, you would have a 0 there. And there's no 0, so there's no numbers in the 40. Notice 60 is right there. Okay, histograms. Histograms are like bar graphs. The difference is they are intervals. Meaning instead of one specific number, you'll have a range, a variety. Notice down here we have number of shipments and number of broken plates. The intervals are 1 to 5 are broken, 6 to 10 are broken, 11 to 15 are broken, 16 to 20, etc. Okay, so they're intervals, they're not one particular number. So how many shipments have between 16 and 20 broken plates? So 16 and 20 is this interval, and I am at 6. 6 shipments have between 16 and 20 broken plates. And which ranges of roses per bush occurred least frequent? 20 to 29, that's right there. 50 to 59, obviously, but we'll just continue forward. 60 to 69, right here. 80 to 89, right here. So obviously it is the 50 to 59 is the least because there was 1, right? Okay, let's go to Professor Jefferson before we do the other one. Professor Jefferson released the results of yesterday's pop quiz. Oofta, didn't look so good. Before you answer this one, I want to know how many kids took the quiz. That's a good question. How many total kids took the quiz? 5 here, 7, 1, 1, 8, 12, 22. 22 kids took the quiz. And then are there fewer students who scored 1 to 5 points or 16 to 20? Which one had less?
16 to 20.
16 to 20. I don't think his class did so hot on this quiz. I don't know. Look at how many students scored between 1 to 5. That's not a good score. No. Okay, so looking at the next histogram, again, intervals. How many packs are there in all? So these are broken cookies. And how many in a package? So we would have 7 had 1 to 5 broken. 5 had 6 to 10 broken. 7 had 11 to 15 broken, etc. So I'm just finding the total for the interval. And then you add those up, and what do you get?
40.
40 in total packs. Now this is an MCA level question, this last one. This last one says, which statement is true? I can tell how many packs broke exactly 12. So I'm gonna just